Hey, Abraham, good morning.
Hello, ma'am. Good morning.
Morning. Okay. Now, 16th chapter. We hear various types of voices in the environment. The sculling of leaves and whisper of rains gives us the idea about the weather outside. We talk to each other to express our feelings. A child explains all his needs by sounds. Therefore, sound has a great effect on our life. How a sound is produced, how it is transferred from one place to other. Is there any difference between various types of sounds? How can we hear a sound? We will learn about all this in this chapter. Okay. Now there are a lot of sounds that we hear around us. Okay, the sounds of the birds, the sounds of vehicles that are going on the road outside. Then when we talk to each other, those sounds. Then the sound of leaves rustling when the wind blows, and the sound of music. There's a lot of sounds that we hear every day. In this lesson, we will see how a sound is produced and how sound is transferred from one place to another. Okay, then is there any difference between various types of sounds? Okay, so let's see what is sound. Sound is an important form of energy. It connects us to environment and let us know the changes in the environment. Okay, it lets us know the changes in the environment. We learn what is happening around us by sound, by listening to the doorbell or thumping on the door. We know that somebody has come to meet us. Okay, before the guests come and before we see them, we may hear the doorbell. Okay, or they're knocking on the door, and then we will know that oh, somebody is there, and then we will see them. Right, so we identify it by the sound. Similarly, a lot of things we identify by the sound, like raining. Okay, the sound of the rain. We are inside a closed room and we hear the rain outside. Okay, we have not seen it yet, but we can hear the sound, and that is how we will know that rain. It has started raining outside. Same with thunder. Okay, the sound of lightning. Okay, the sound of lightning. We will hear it. Okay, we'll hear the sound of thunder, and then we will say, "Oh, lightning is there." Okay, or thunder happened. Then, same way, we our environment produces a lot of sounds, and we identify what is going on in the environment or what change has taken place by listening to that sound. When we hear the sounds of footsteps and we understand that somebody is walking. Think, how do you know that air is blowing outside or it is heavily raining without seeing? By the sounds, by their sounds, then by the sound of an instrument, we will identify if it is a flute or a drum or bell. Right. We listen to the sound of an instrument and we can identify it. Even if you're not seeing, okay? If guitar is being played, we'll hear its sound and we can identify it is a guitar that's being played in that song. Okay? So by listening to it, to the sound, we can identify. Then sometimes even we can differentiate also. Okay? Say the way our mother is walking, the way our father is walking, the way our sibling is walking. Okay, the way a brother or sister is walking. By listening to their footstep sound, we can differentiate also. Okay, that mom went by, or dad is walking, or my sister or brother came, right? By the sounds of their footstep, because it is different. It is slightly different from one another. Okay, so that also we can tell without looking. Now, prepare a list of sound around you and you will know the major changes around you. Okay, these are all the changes that takes place. Changes in the weather, changes around us in the environment that we can identify by the sounds, by their sounds. Now, there's an activity 16.1. Take a metal utensil, Hang it in such a way that it does not touch your wall. Now hit it by a stick. Touch your finger after hitting. Do you experience any vibration? Again, hit the plate by a stick and now tightly hold it using both hands. Did you listen any sound now? When plate stops producing sound, touch it again. Do you experience any vibration now? Okay, so basically it's saying that when we hit something, okay, vibrations takes place. Okay, along with the sound, vibrations takes place. Take a metal plate and put some water in it. Now hit it with a spoon from a corner. Do you listen any sound? Hit the plate again and touch it. Do you feel any vibration? Again hit the plate and see on the water level. Do you find any waves? Okay. So what happens is that when it's a plate full of water, water will vibrate. Okay. Waves will be formed in the water. And when we hold it with both the hands, it will be stilled again. Okay. The vibrations will stop again. Now, you must have understood that the items producing vibration produce sound. Okay, those items that produce vibration produce sound. This is seen in some situations. It is difficult to actually see the thing vibrating all the time. Okay, difficult to see vibration in most of the situations. Reason behind is that we cannot see vibration with our eyes. We experience the sound. In reality, every source of sound is a vibration during a vibration doing thing or an item. Okay, when we are speaking, our vocal cords vibrate. Okay, our vocal cords vibrate when we are speaking. Try to speak something and place your hand on the voice box and try to speak something. You will feel the vibrations, slight vibrations you will feel. Right, so while speaking, here it vibrates, and everything that produces sound, vibration takes place in that. Okay, now what is vibration? When an item moves to and fro from the center, it is known as pendulum or oscillation. Okay, and we will see vibration in more detail. Now, take a strong thread and attach a stone at one corner of the thread. Put a nail on the wall. Now hang the stone by using the other end of the thread. Observe its motion. Okay, so this is pendulum motion where it goes from the left to right, then left to right. Okay. Yes, Abraham.
Did you know, ma'am, when the pendulum goes up, it has no kinetic energy, but it has potential energy. But when it's coming to the other side, it has kinetic energy and then it has potential energy. And the
Yes,
reason
Abraham.
it never continues forever and ever, ma'am, because all the forces that are acting upon it, such as friction and gravity,
Yes, Abraham. That is true.
not gravity, such as friction and resistance.
Sorry. Friction we have. Friction is acting upon a pendulum when it's moving. True. Now, the stone moving from A to B, then B to A to C, and finally to C to A is a full circle of one pendulum. Okay. This is A, this is B, and this is C. Okay. So a pendulum starts moving from A to B, then again comes back B to A, and then A to C, C to A, and A to B. That is the full circle, okay, of one pendulum. The time taken by a stone to complete one pendulum is known as oscillation time. Okay, this pendulum motion is also known as oscillation. Okay, and the number of pendulums completed by the stone in a second is known as frequency. of the pendulum. Okay, the number of pendulums or the number of a complete pendulum completed by the stone in a second is known as frequency of the pendulum. It is measured in hertz. Okay, measured in hertz. Frequency is measured in frequency is measured in hertz. Okay, Hz is the symbol. Frequency is always equal to one pendulum per second. Means that one pendulum movement in per second.
Ma'am, what's the symbol, like the full form of words? Is there any full form?
No, Abraham. Hertz is a full form. Hertz is the full form. Okay. Now, the maximum displacement of stone from the middle point A is known as dimensions of pendulum. Okay. Maximum displacement means maximum displacement will be either A to B or A to C. Okay. So these are known as dimensions of pendulum. Okay. Dimensions from A to B, A to C, dimensions of the pendulum. Okay. Then time taken to complete one pendulum known as oscillation time. Okay. And the number of pendulums completed by the stone in 1 second are known as frequency, is known as frequency, which is measured in hertz. Okay. And it is always equal to one pendulum per second. Okay, sound is a form of, let's try it in text question 16.1. Sound is a form of, yes, Emma?
Ma'am, sound is a form of energy.
Yes, sound is a form of energy. Sound helps us to know dash in the environment.
About sound helps us to know. Ma'am, I don't know.
Emma? Sound helps us to know dash in the environment. Can you hear me, Emma? Emma, can you hear me? Hello? Unmute, Emma. Unmute and say,
Oh, yes, ma'am. So for number two, right? Sound
yes.
help us to know dash in the environment. Um, ma'am, ma'am, 1 second, ma'am. I'm just gonna have water and coffee.
Hmm.
Know the placement of things in the environment.
No, changes in the environment. Okay, changes in the environment. Next one, vibrating items produce,
Sound,
yes. Frequency is measured in,
Hertz.
yes, hertz. What do you mean by vibration of pendulum?
Ma'am, vibration and pendulum is not the same thing.
Yeah, it's not the same thing, but here they have asked it.
Vibration and the back and forth movement or the up and down movement of particles in a solid. And by pendulum, I mean the oscillatory movement seen in a stone when you push it connecting it to a rope.
The to and fro motion, the to and fro motion of a pendulum or a stone, okay, to in two dimensions, that is like on one side and the other side, that is known as pendulum, okay, or oscillation. Then sound produced by humans. You know that humans produce sound with the help of their throat. Keep your hand on your throat and you will find a hard bump. Okay, this hard bump is a voice box or the vocal cords. When you eat or drink something, this body part moves. This is known as vocal cords. These vocal cords are on the upper end of the breathing pipe, and vocal cords have two voice boxes which have narrow passage to the air. Okay. Then muscles related to vocal cords can make cords tight and loose. When lungs forcefully push the air out, then vocal cords get vibrated and produce sound. Sound is different in both loose and tight cords. Okay, so this is our voice box. Okay, or our vocal cords, and the movement of air. Okay, the movement of air that takes place through it produces sound, causes vibration in our vocal cords, and produces sound. So now we have loose vocal cords also and tight vocal cords also. Okay, and the muscles that are near the vocal cords can make them tight or loose. Okay, sound is different in both loose and tight cords. I think this is about the tight and loose vocal cords. Also, like the tight and loose vocal cords, it becomes with age also. Okay, for the young people, the vocal cords are tight, much more tight. But for the old people, the muscles, because they become a little loose, the vocal cord might be a little loose, which causes them to make sounds. Okay, make not very sharp and not very strong, but old people say very softly, like they talk softly, okay, compared to the young people. Okay, so I think that is the reason why there's a difference in the tight and loose vocal cords. Now, do you know that the length of vocal cords in males is around 22 millimeter and females have 15 millimeter? Okay, the difference of male and female vocal cord is 5 millimeter. In males, it's 20 millimeter. Females have 15 millimeter vocal cords, and in children, they have more smaller vocal cords. Therefore, the sound of women, men, and children are different from each other. Okay, the sound is different from each other. Males have much heavier voice compared to the women. Okay, because of the difference in their vocal cords. Okay, difference in the vibration that's taking place there. Now, so this is about the sound that is produced by humans. We will see how sound travels. When sound source starts vibration, then the molecules of air also vibrate. These make other elements present in them also vibrate. In this way, the process goes on. The sound then reaches from one place to another by the means of air. Therefore, we know that sound needs a medium to move. Sound moves in all three mediums: solid, liquid, and gas. Okay? In solids, in liquids, and in gas, all the three mediums, sound moves. Okay? I'll show you one diagram of this. Okay? I'll show you one diagram of this movement of sound. Now, we know that the molecules of solids are tightly packed together. The molecules in liquids are a little away, but the molecules in gases are the most away, means very loosely packed. Okay. So now because sound moves, okay, because sound moves, it causes vibration in these molecules. It causes vibration in these molecules. This vibration happens in the connected molecules. Then that vibration in the connected molecules. Okay. Now because the molecules in the solids are tightly packed, they will one will start vibrating and the other will start vibrating faster because they are close. But in liquids, it will take a little bit of time, and in gases, it will travel the slowest because gas molecules are far away from each other. Okay, so sound travels through solids, liquids, and gases. Okay, through solids, liquids, and gases. Okay, all the three mediums, but with different speed. With different speed. Okay, in the first one, you can see the white lines is the sound. Okay, it will travel fast because the proximity means the distance between the molecules of the solid is very less. They are very close. In the liquid, okay, they are a little apart, so it will be slower than the solids. The speed of the sound that is traveling through, okay. Then in the gases, the particles, the molecules are even further apart. So it will take more time than liquids for sound to travel in gases. Okay. Understood how vibration takes place here? Okay. Vibration takes place here. One molecule starts vibrating, then the complete vibration takes place, and that vibration, okay, will help, will make that vibration will make your sound will make your sound travel from one place to the other. Okay, from one place to the other. Now, any doubt in the traveling of sound? No. Listening sound. We already know that sound is produced by vibrating objects and they can be sent in any direction and any medium. Let us know how a sound is listened. Now, how we listen to it. We saw how it is produced, okay? We saw how it comes out of us, out of our vocal cords. We saw how it travels. We will see how we can listen to it, okay? Now, we know that we hear by our ears. Okay? Our ears are the parts that helps us to listen to the sound. The outer shape is like a keep. Okay, the sound enters there and then moves in a pipe after entering our outer ear. The pipe has a thin layer known as eardrum. Eardrum is an important part. Okay, let's see what is the function of an eardrum. Here's the activity. Take a plastic or tin box and cut both the ends of the box. Place a balloon on the other end and bind it with the help of an elastic rubber. Place rice or wheat grains or thermocol above it. Now speak hooray, hooray on the other end and see what happens to grains. Eardrum is just like a stretched rubber sheet. The sound gets vibrated just like in the above activity. When you shout inside, the grains will, the rubber band will, the rubber that is stretched will vibrate and the grains will bounce a little bit. Okay. And the same thing our eardrum is doing. It's just like a stretched rubber sheet. Sound gets vibrated. These vibrations are sent to the internal ear after these codes are used as symbols by human mind. In this way, humans can listen to the sound. Okay. What happens is that I will show you English diagram. Check this out. Sound waves are collected by the outer ear pinna and travel down the ear canal to the eardrum, causing it to vibrate. These vibrations pass through the middle ear's three tiny bones. In the middle ear, there are three tiny bones called as malleus, incus, and stapes, which amplify the sound and send the waves to the ear's inner cochlea. Inside the cochlea, specialized hair cells convert these fluid vibrations into electrical signals, which are then sent to the brain via the auditory nerve and interpreted as sound. And the brain will give its meaning. Yes,
Ma'am,
Ibrahim.
can you show us a video on this, ma'am?
A video on this. We can see a video on this. Okay. We can see a video on this.
Have you ever wondered how sounds make their way from the source all the way to your brain? Take a trumpet, for instance. When it's played, it makes sound waves in the air. The outer ear catches the waves, which then travel through a narrow passageway called the ear canal. The sound waves reach the eardrum, which is a membrane roughly half the size of a dime. They make the eardrum vibrate, which in turn vibrates three tiny bones called the malleus, incus, and stapes. These bones amplify or increase the sound vibrations and send them to the cochlea. The cochlea is shaped like a snail and is the size of a garden pea. It is filled with fluid, and the sound vibrations make this fluid ripple, which creates waves. Hair-like structures called stereocilia sit on top of hair cells and are grouped together as hair cell bundles inside the cochlea. The hair cells inside the cochlea ride these waves, and the hair bundles are moved. The hair bundle on top of the hair cell turns these movements into electrical signals. As the hair bundles are moved, ions rush into the top of the hair cells, causing the release of chemicals at the bottom of the hair cells. The chemicals bind to the auditory nerve cells and create an electrical signal, which travels along the auditory nerve to the brain. Different hair cells respond to different frequencies of sound. The hair cells at the base of the cochlea detect higher-pitched sounds, such as a piccolo or flute. The hair cells toward the top of the spiral detect progressively lower pitched sounds, such as a trumpet or trombone. At the very top or apex of the spiral, the hair cells detect the lowest pitched sounds, such as a tuba. The auditory nerve carries the electrical signal to the brain, which interprets the messages as sounds that we recognize and understand.
Understood how it works?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. What's the most interesting thing is that the cochlea, it has like for all the three types of frequencies, it has the hair that will like translate it into electrical waves and send it to our brain for us to interpret. Okay, that is how we can detect all types of sounds. We can see the sounds which are high pitch, okay, low pitch, and very low pitch. All the three sounds we can detect. Okay, our brain can understand them. That was interesting. Okay, so we will stop here in science. We will stop here for today. And tomorrow, we will see what are the various types of sounds. Okay, tomorrow we will see what are the various types of sounds. Okay, 5 minutes break for you all, and then we'll do maths. let's begin. Turn on your videos.
Hi, ma'am. Good morning, ma'am.
Hi, Joshua. Good morning.
Ma'am, I have a question, ma'am.
Yes.
Do we start at 8:20, ma'am?
8:20. 8:20, Joshua. We start at 8:20.
Okay, ma'am.
Okay? Yes. Okay, Abraham, now videos on. Today we will try out some questions from the compound interest. Yesterday we saw what are the formulas that we use to calculate compound interest. Okay, today we will try them out. Let's check out this question. Find the compound interest find the compound interest and the amount of rupees 1,000 at the rate of 5% for 2 years, 5% for 2 years annually, compounded annually. When it is annually, what do? We write the amount form. See, first step 1 is calculate amount. Okay. Step 1, we calculate the amount. Amount is equals to principal 1 plus r upon 100 raised to the power n. Okay. Raised to the power n. Now, in this question, principal is 1,000, rate is 5%, and that is the time is 2 years. Here 2. I have to find out the amount, and then using the amount and principal, we will find out the compound interest. For amount, write the values now. P means 1,000, write 1,000 outside. Write 1,000 outside. Then put the bracket 1 plus, what is our 5 upon 100 raised to the power n is 2 raised to the power 2. Okay, now we will solve it. Now, first we solve what is inside the bracket. How? Take the LCM. Take the LCM of 1 and 5 upon 100. Okay, we take the LCM. Okay, how much you will keep in the denominator? You can keep 100 in the denominator. Okay, you can keep 100 in the denominator. I'll write it directly. We can keep 100 in the denominator. Okay, in the table of 100 is coming how many times? 100 times. So 100 plus, in the table of 100, 100 is coming 1 times into 1, 5, 2. Okay, 1,000 multiplied by, 1,000, then inside the bracket 105 upon 102. You can cancel also 105 and 100. You can cancel here. Okay, you can cancel here with 5. 5 2s are 10 and 0, 5 2s are 10 and 1, 15. So 21 upon 20. You will get how much? 1000 into 21 upon 20. Now see, the power that is here, the power that is here is of 2. The power that is here is of 2. So you have to write this 21 upon 20 two times. Okay. Now you cancel 0 with 0, 0 with 0. Okay. 2 2s are 4, 2 also, 2 1s are, 2 5s are 10. Okay. You multiply 5 times 21, 5, 21 and 21. Okay. And then divided by 2. Okay. Divided by 2. How much you will get?
20 divided by 2, ma'am.
5 into 21 into 21 divided by 2. 2205 divided by 2. You will get 1102.5. 1102.5.
Ma'am,
Now,
it was 5 times 21 times 21
yes, 5
divided by
times
2.
21 times 21 divided by 2. Yes, Joshua. Okay. How much I will get? 1102.5. Okay. This is my step 1. Now, step 2 is very easy. Okay. Step 2 is very easy. In the step 2, what we will do? Here I will write step 2 this side. Step 2, you have to calculate compound interest. So CI is equals to A minus B. Okay. What is A? This is A that we just calculated. This is A. Okay. So 1102.5 minus 1000 minus 1000. P is how much? 1000. So your CI becomes how much? 1002.5. 02.5. Okay. Once again, I will explain it. Okay. There are two steps when we are doing compound interest. There are two steps. The first step, you have to find out the amount A. First step is A, and second step is CI. Okay. For A, this is the formula. I taught you all the formulas yesterday. Okay. It says annually. Annually. That is why only R and N I have written. Okay. Put the values. Principal is 1000. Okay. Then 1 plus R by 100. R is how much? 5. So 5 I have written here. Okay. N is how much? 2. So 2 I have written here outside. Okay. What does it mean when you have a number like this? 3 outside the bracket. It means that I have to multiply 3 with itself 3 times. Okay. This is the meaning of par. This is known as par. This small 3 is known as par. Okay, Joshua? If I have 12, look here on the screen. If I have 12 and I've written 5 over it, small 5, means it will become 12 into 12 into 12 into 12 into 12. 5 times I have to multiply 12 with itself. 12 with itself, not with 5. Don't do 12 fives out. Okay? 12 with itself 5 times. So this is par. Same thing here we will do. Okay? Same thing here. I have done. What I did is that first I solve what is inside the bracket. Always solve first what is inside the bracket. Do you know how to take LCM and do addition? No?
Ma'am, can you just explain how you got the M to be 2?
N Abraham is the time period. Okay, the time period. When we are doing compounding annually, when you're doing compounding annually, you will have only n views. Okay, and the number of years that will be given in the question, that will become your n when you're doing it annually. Just put the number of years here.
Ma'am, can
Okay.
you give
Yes, I'll give you a question like this. Then I took an LCM, okay, and added inside the bracket. So I got 21 upon 20. Then I did 1000 multiplied by, because a multiplication sign is there. So 1000 into 21 upon 20 into 21 upon 20, I got 1102.5. Okay. And then step 2, from 1102.5, I subtracted 1000 to get 102.5. Okay. Write this down. Have you written this? Yes, Abraham. Yes, Abraham.
Ma'am,
Cannot hear you. I cannot hear you. I will give you a question like this to solve. Okay. Now, in this question, principal is 5000. Okay. Rate is 10%. Time, or your N, is 2 years compounded annually. Solve this. Okay. Solve this. Use the formula. Use the formula. A is equals to P 1 plus R upon 100 raised to the power n. Use this formula and find out the value of A.
Is the answer 150?
150.
1000, sorry, 1050.
1 second, Emma. Let me see and tell you.
Ma'am, I found the amount. Can I say the answer, ma'am?
Ma'am,
Yes, Abraham.
Ma'am, 550 mine, ma'am, the answer is 600. Say 6050.
6050. And Emma, what did you say? What is the
ma'am, I
CI?
was just saying that I have done this like before in mental math. So I also calculated the compound interest, which is
What is
1050.
1050? Correct, Emma. Correct, Abraham. Okay. Good. Both of you are getting correct answers. Well done. Okay. Okay. Now,
Ma'am, I'm also getting 1050.
1050 is the correct answer. Okay. We put in the values. Simple. 5000. 1 plus 10 upon 100 raised to the power 2. Okay. Then 5000 LCM 100. Okay. 100 plus 10 raised to the power 2. 500 or 5000 into 1110 upon 100 into 1110 upon 100. Cancel out the zeros. Multiply 5 with 110. 5 times 110 times 11. 11. You will get how much? How much? 5 times 110 times 11. 6050. Okay. Then I'll find, in the second step, I'll find my compound interest. CI is equals to A minus B. What is A? 6050. And what is P? 5000. How much? 1050. Okay, understood? Joshua, understood?
Not really, ma'am.
Not really. Okay. Which part did you not understand? Can you tell me?
Second step.
This
Second,
one?
third. No, ma'am. It's minus 5000, then bracket 1 plus 10 by 100, and then the 5100 plus 10 by 100.
Okay. Okay, Joshua. So what we do, Joshua, is we are adding the fractions using LCM. Okay. What is that? Suppose I have to add two numbers. 2 plus 4 upon 8. Okay. If I'm adding, I have to add two numbers. 2 plus 4 upon 8. Okay. Now 4 upon 8 is a fraction.
Yeah.
Okay. And 2 is a single number. So beneath 2, I will write 1. Okay. Then we have no denominator, means 1 is there. Then you put one line and write 8 here, the bigger number. Okay. Then you see that in the table of 1, in the table of this 1, how many times this 8 is coming? Tell me, in the table of 1, how many times 8 is coming?
1. Sorry,
In the
8.
table, 8 times, right? 1 8s are 8. So this above number, that is the 2, you will multiply it with 8. Okay. Then look at this number 8. How many times in the table of 8 is coming? 1 time. Okay. So you multiply the above number 4 with 1. Okay. You multiply the above number 4 with 1. Now write them. Now we will write them. Okay. How? 2 8s are 16 plus 4 1s are 4. Okay. Divided by 8. 8 is below the line. Now 16 plus 4 how much? 20 by 8. Okay. So this is what we are doing, Joshua.
Ma'am,
Here.
I understood all that, but I was trying to understand how you got the R.
How I got the R.
Yes.
10 how I got the 10. See Joshua, look here. R means the rate and it's always given in the question. Okay.
Not that, ma'am. The 160.
160.
Yes, ma'am. 160 is underneath R.
160 is not on the okay. This is 0, Joshua. This is 100.
Oh, okay, ma'am.
This is not 160. This is 100. Okay. And it comes from the formula. This formula I taught you yesterday, right? This formula I taught you yesterday. Okay. It's a part of the formula because rate is in percent. Rate is in percent. And anything is in percent, we put that and put 100 beneath it. So R upon 100 because rate is in percent. Okay. That is why R upon 100. Okay. Did you understand how I did this? How I did this? See, beneath 1 I put 1. Then I took the bigger number 100 here. Then I saw in the table of 100, in the table of 100 is coming how many times? 100 times. So 1 into 100. In the table of 100 is coming how many times? 1 times. So 10 into 1. 1 into 100, 100. And 10 into 1 is 10. So add 110, 110. 110 equals to 110, 1110. Okay. So that is why I got 1110 upon 100. And because it is raised to the power 2, okay, because 2 is outside, so 2 times I will write it. 2 times I will write 1110 upon 100 into 1110 upon 100. Okay.
Okay,
Got
ma'am.
it now? Got it now?
Yes, ma'am.
Okay. Okay. One more question I will teach you. One more question I'll teach you for compounding half yearly. Okay. For compounding half yearly. See, this time principal is how much? 4,000. Okay. Rate is how much? 10%. Time or N is how much? 1 year. 1 year compounded half yearly. Okay. Now see the changes in the formula. See the changes in the formula. Okay. A is equals to P 1 plus R by 2 upon 100 raised to the power.
Ma'am, now n will become 1 into 2, right?
Yes, Abraham. N will become 1 into 2. Okay. Now n will become 2n, means 2 into n. N is what? N is how much? 1. Okay. So 2 into n, 2 into 1, 2. Okay. Now I will put the values and I'll show you. Principal is how much? 4,000. bracket 1 plus. Rate is 10. 10 divided by 2 upon 100. 2 into 1. Okay. 2 into 2n means 2 into n. N is how much? 1. So 2 into 1. Okay. So 4000. 10 divided by 2 is how much? 5. 1 plus 5 upon 100 raised to the power 2 ones are 2. Okay. 2 ones are 2. Now 4000. Take the LCM. 100 again. Okay, in the table of 100 is coming 100 times 1 into 100. In the table of 100, 100 is coming 1 time, 5 into 1. 1 into 100, 100 plus 5 ones are 5 raised to the power 2. 4000, 100 plus 5, 105. So into 105 upon 100 and 2 is there, so into 105 upon 100 again. Okay, now cut 0 with 0, 0 with 0, 1, 0 with 1, 0. Okay, 2 2s are 4, 2 5s are 10. Okay, 5 1s are 5, 5 2s are 10, and 5 1s are 5. You have 2 times 105 times 21. Multiply. Multiply this.
4410.
How much, Abraham?
4410.
4410, Abraham. Correct.
The
Okay.
person who made 10% interest.
Say again.
And the person only made 10% interest. Not
Yes.
10 that it has interest.
Yes, the person only made 10% interest. Okay.
Ma'am,
Yes, yes, Joshua.
isn't this sort of like harder?
Little bit, Joshua. Little bit it is. Little bit it is. Okay. But once you get a hold of it, it will become very easy. Okay. Once you like understand, grab the concept and able to calculate, it will become easy. Okay, don't worry if you're not able to understand the whole thing right now, but slowly, slowly you will be able to do it. Okay. You'll be able to do it slowly, slowly. Now, CI is equals to how much? A minus
410, not 10.
410. Sorry, yes, Abraham, 410. I thought you were telling 10% rate.
And then the answer is 4410.
Yes, the answer is 4410 and CI is 410 because 4410 minus 4000 is equals to how much? 410 rupees. This is your second step, compound interest. Okay. Write this down, please, and then I'll give you one question to do.
Ma'am, all the situations we are doing now, they are all hypothetical situations. Right?
They
Meaning
are
like
all
hypothetical situations, meaning like, ma'am, the real amounts will be much more, right?
the real amounts will be much more, Abraham. Okay, that is true. Real amounts are usually much more. Okay, like 9,000, 10,000. Okay, 3 months for 3 months, for 6 months even more. Okay, so yes, these are hypothetical situations, but the concepts are practical, are actual and practical. Okay, the real life also this only happens. Okay. Okay, Joshua, today I want you to practice some questions with your mama on fraction. Okay, on addition in fractions. How do we add fractions, Joshua? And how do we work with powers such as 3 raised to the power 3,
Ma'am,
Okay.
uh,
Yes.
you said work with? I didn't hear that part, ma'am.
Work with your mama. Okay. Sit with your mama and solve fractions. Okay.
I understood
Sit
that,
with your.
ma'am. But then after you had said that, you said before you started writing the three, you had said something.
I said that today you sit with your mama and do addition of fractions, okay, and do power questions also, like 3 raised to the power 3, how do you do 3 into 3 into 3, okay, or then there is, say, 4 upon 3 raised to the power 3, how you do it as 4 by 3 into 4 by 3 into 4 by 3, and then cancel and find out the answer. Okay, so this thing you have to sit with mama and learn, okay, and practice more. Understood?
Yes, ma'am.
Okay. Okay, so quickly I'll give you one question to try out. Have you all written? Shall I clear the screen?
Yes, ma'am.
Okay, ma'am.
Okay. Now, see, the principal is 7,000. Rate is 10,000. And time is 1 year. Okay. And compounding is half yearly. Find out the amount, find out A and CI. Find out A and CI. Use the formula for A equals to P 1 plus R by 2 by 100 raised to the power 2n.
Ma'am, the
Yes, ma'am.
answer for the amount is 7,717.50 and compound interest is 717.50.
Now I'm getting the same answer.
You are getting the same answer. Let me just quickly check it and confirm it to y'all. Okay, correct. Abraham and Emma, correct. Correct answers all together. Very good. These are the answers. Okay. We put the values. Okay. P 7,000. 1 plus 10 upon 2 by 100. 2 into 1. 7,000. 1 plus 5 upon 100 raised to the power 2. 7,000. 1 LCM 100. 100 plus 5 raised to the power 2. 7,000 into 105 upon 100 into 105 upon 100. Cancel the zeros. 5 2s are 10. 5 2s are 10 and 1s are 5. Multiply 7 times 21 times 105 and divided by 2. You will get 7,717.50, which is your amount. A. This is your A. Second step, calculate CI equals to A minus B. A is 7,717.50 minus B is 7,000. How much you'll get? 717.50. Yes, Abraham.
Ma'am, why are you not canceling, ma'am?
Where, Abraham?
Ma'am, like before you started it, you used to cancel 105 and 100 and get it to 21 upon 20.
Yes, Abraham, it is the same thing. Either you can cancel 105 and 100 and bring it to 21 upon 20 and then do 21 upon 20 to 21 upon 20. Or directly put 105 upon 100 into 105 upon 100. It's the same thing. Okay. I'll do that from now on. If that makes it shorter for you, I'll do that from now on. Okay. Okay, Joshua, written?
Yes, ma'am.
Okay. Okay, then tomorrow I'll teach you quarterly and I'll practice some more questions like this with you.
Pardon, ma'am?
Tomorrow I will teach you quarterly
Quarter.
basis, compounding quarterly. Okay.
Okay, ma'am.
Okay. Okay, then I'll see you all tomorrow.
Bye.
Tomorrow is maths quiz.
Okay, ma'am.
Tomorrow is maths quiz. Friday, right? Yes.
Yes.
Tomorrow is maths quiz. So please prepare the percentage topics from the percentage chapter for maths quiz. And tomorrow, yes,
Then I think you should have send what topics are coming.
I told you what topics are coming in the class, right?
Percentage.
So you'll send it to our parents.
I'll send it in the group today if you want me to, okay? Okay then. See you all tomorrow. Bye.
Bye, ma'am. Ma'am. Bye, Abraham. Bye, ma'am.